Now let's start with general theory of relativity. We were reading about gravitational waves, है ना? Gravitational waves क्या है? हमने देखा था कि स्पेस जो है, स्पेस itself is a sheet and things when they have mass they bend that sheet. Gravity bends space, right? And अगर दो बहुत ही हैवी चीजें, जैसे मान लो जिन्होंने इसको बेंड कर रखा है इस शीट को, दो बहुत हैवी चीजें, दे कम एंड कोलाइड विद ईच अदर और दे स्टार्ट रिवॉल्विंग अराउंड ईच अदर, दे विल create ripples in this sheet. जैसे ripples produce होते हैं when we throw one rock in a pond. So if that thing happens in space, that is called a gravitational waves, right? Gravitational wave कब होता है? When cataclysmic events happen. Cataclysmic means events such as colliding black holes, supernova explosion, colliding neutron stars. Now these are gravitational waves. तो gravity क्या करती है? It stretches and squeezes things, bends things. So they are waves that stretch and squeeze things in their path, and they travel at the speed of light because they are waves. Okay, so they travel at the speed of light and they stretch and squeeze anything in their path. Okay, now gravitational waves were detected in LIGO, the Laser Interferometer Gravitational Wave Observatory, right? कैसे डिटेक्ट करता है? पहले हम ये ग्रेविटेशनल वेव का थोड़ा आइडिया देख लेते हैं कि these are two very heavy things that are rotating like this. Now these things, what they are doing, they are very heavy and once they come into this sheet they start rotating or they collide. ये ripples, ये वाले जो ripples हैं, ये ripples produce होने लगेंगे. ओके, ये रिपल्स जब प्रोड्यूस होने लगेंगे दैट विल बी कॉल्ड अ ग्रेविटेशनल वेव. अब इसको टेस्ट कैसे करते हैं ये हम कल पढ़ चुके हैं. दिस इज द लेजर इंटरफेरोमीटर ग्रेविटेशनल वेव ऑब्जर्वेटरी. इसमें क्या है? दो बहुत बड़े स्केल हैं 4-4 किलोमीटर के, राइट? देयर आर टू वेरी बिग 4 किलोमीटर स्केल्स. जब ग्रेविटेशनल वेव आएगी इट विल स्ट्रेच एंड स्क्वीज एवरीथिंग इन इट्स पाथ. तो ये बट द थिंग इज इट हैपेंस एट अ वेरी मिनिस्क्यूल लेवल. बहुत दूर से वेव आ रही है तो हमें बहुत सेंसिटिव इंस्ट्रूमेंट चाहिए. तो देयर आर 4 किलोमीटर लॉन्ग 2 स्केल्स, दे विल स्ट्रेच एंड स्क्वीज. तो यहाँ पे ये 4 किलोमीटर से मान लो 4.0001 किलोमीटर हो गया स्केल में तो चेंज नहीं होना चाहिए, राइट? बट इफ देयर इज अ ग्रेविटेशनल वेव, दिस स्मॉल स्ट्रेचिंग एंड स्क्वीजिंग विल हैपन एंड दिस स्मॉल स्ट्रेचिंग एंड स्क्वीजिंग विल बी ट्रैक्ड. दिस इज व्हाट द LIGO does. Now, LIGO is doing this on Earth. Problem क्या है कि Earth itself has gravity. तो हम डिटेक्ट तो कर सकते हैं on Earth, but if we detect on Earth, तो Earth की gravity से हमको disruption हो सकती है, थोड़ी distraction हो सकती है. There might be certain interference. So what do we need? We needed something in space to do that. So for that we made the evolved LISA, right? This is the gravitational wave from space. इसने क्या किया? It took 3 satellites that made a 1 million kilometer long equilateral triangle. अब ये क्या हुआ? What is this 1 million kilometer doing? This is acting like that scale क्योंकि हमने लेजर बीम्स यूज करी. ठीक है, we are using the laser beams. अब इन लेजर बीम्स में these are like scale for us. Now when there will be stretching and squeezing, this 1 million kilometer, this might change. थोड़ा सा ही चेंज होगा बट चेंज होगा. So this interferometer, the LISA, is capable of detecting gravitational waves in space, and since it is in space, it is not interfered with by the Earth's gravity. It is much more sensitive. तो यहाँ यही बात लिखी है, such a frequency interval is not accessible on Earth because terrestrial gravity noise, meaning that Earth's gravity is doing some interference. So ELISA looks like this. ये हमने कल देखा था. Laser beams like this. Now if there is some stretching and squeezing in space, so there will be tracking on the ELISA. Okay, next हम देखते हैं gravitational lensing. This is something we did not study yesterday. तो यहां तक clear है सबको? This is conceptual, so I'll go slow. all electromagnetic radiation. Okay, how is a wave stretching or squeezing anything? Because it is, gravity is what? Gravity is the bending of space, right? Now when the bending, gravity is what? It is the bending of space. Okay, something like this जो हमने कल देखा है. Now let's say two things that bend space, they have collided, right? So there will be a wave of gravity, because there is a, now exactly how this happens is not even clear to NASA, right? Even they don't know why this gravitational wave is produced. But what you have to understand, or the thought experiment that you can use, is that gravity itself is the bending of space, right? It bends space somewhat like this, like we saw on that trampoline sheet yesterday. So when two things that are bending space, they come together, they collide, or they revolve around each other, they will produce ripples in this trampoline sheet. Now ये जो ripples produce हुए, what is that? First, it is a radiation. All electromagnetic radiation, this is not electromagnetic radiation, but all other electromagnetic radiation traveled at the speed of light. So it was found, देखो, there are two types of scientific findings. One is observed and one is inferred. Observed things means that we just found that it happens like this. Inferred means that from our calculations we were able to infer, or we were able to calculate that gravitational waves would go like this. Currently the findings around gravitational waves are mostly observed findings. We have just observed how these gravitational waves work, right? Because abhi we are still in the process of understanding how they work. So what we have observed in gravitational waves is that it is a wave of gravity. Gravity's job is to bend the space around it. When it bends space, it brings things closer, right? Of course, gravity does bring things close. Tabhi to sun ki gravity is making earth revolve around it. So a wave of gravity is formed. A wave of gravity would mean that this bending or bringing things closer would mean squeezing. If this is me, I'll just explain on a different page. If this is me and I have huge mass and this is you, gravity would mean that I bend the space around to bring you closer, not attract force. This is what Einstein was saying. This is what we were discussing yesterday. When this is the sun and this is the earth, it is not that the sun is attracting the earth directly. It is just bending the space like this. That is making the earth revolve around it. And ये हमने कल देखा है in that trampoline sheet video, right? So now if a wave of gravity comes that travels at the speed of light, this is an observed phenomena. Now what would that do? It would bend the space around between, like the wave would bend the space. Now bending of space would mean what? If this attraction has to happen, what does it mean? You will have to first squeeze the space, and then once the wave passes, the space will come back to normal. So first there will be squeezing and then there would be stretching. This is how a gravitational wave is squeezing and stretching things. Okay, this is too complex physics for you or needed for you. इतनी बिल्कुल भी जरूरत नहीं है. If you have curiosity, we can discuss this at length, but इसकी बिल्कुल भी जरूरत नहीं है. If you just understand that there is a fabric of space, a trampoline sheet of space, gravity bends that space, and sometimes when huge gravitational objects either collide, either they move around each other, what happens? They create ripples in that fabric of space. That ripples, those ripples are what? Those ripples are nothing but waves. These waves are waves of gravity. So they will squeeze and stretch and they will travel at the speed of light. This is what gravitational waves basically are. देखो, now gravitational lensing. Lens क्या होता है? मेरे glasses में there is a lens. Correct? थोड़े गंदे हो गए, but there is a lens. Right? Lens is anything that is distorting light rays. Right? Light rays जो आती हैं हमारी, if light normally आती रहे, उसको अगर हम थोड़ा सा change कर दें, to make it easier for us to see, that is something called a lens. सबसे common lens हमने क्या देखा है? We have seen a magnifying lens. What does a magnifying lens do? ऐसा करके दिखता है मैग्नीफाइंग लेंस, इट लुक्स समथिंग लाइक दिस, राइट। वी पुट इट ऑन अ पेपर एंड वी कैन सी थिंग्स लार्जर, राइट। ग्लासेस में भी लेंस होते हैं, मैग्नीफाइंग लेंसेज में भी लेंस है। नाउ व्हाट इज लेंस डूइंग? जो लाइट आनी थी, किसी भी चीज को हम कैसे देखते हैं, दिस इज द शीट ऑफ पेपर, ओके, दिस इज माई आई, हाउ विल आई सी इट नॉर्मली? लाइट विल कम हियर एंड देन गो हियर, राइट। ये बात तो अपने को क्लियर है। इफ आई पुट अ लेंस हियर, मैग्नीफाइंग लेंस, तो क्या होगा, वो इस लाइट को थोड़ा सा डिस्टॉर्ट करके ऐसा बना देगा, तो मुझे बड़ी चीज दिखेगी। हाउ एग्जैक्टली द रे डायग्राम्स वर्क, स्टेट पीसीएस में पूछते हैं, यूपीएससी में तो दे स्टॉप्ड आस्किंग। सो जस्ट अंडरस्टैंड दैट व्हाट इज हैपनिंग इज इट इज डिस्टॉर्टिंग द विजन। डिस्टॉर्टिंग सीम्स लाइक अ बैड वर्ड, बट वो एक्चुअल से थोड़ा चेंज कर रहा है ताकि हमें बेटर दिख सके, वो मैग्नीफाई कर रहा है, राइट। दिस इज व्हाट अ लेंस डज। लेंस का काम है लाइट रेस को चेंज करना। लाइट रेस को या तो बढ़ा के दिखा देगा या छोटा दिखा देगा। कई लोगों की नेगेटिव पावर होती है, जैसे मेरी है, कईयों की पॉजिटिव पावर होती है। दैट इज बिकॉज लेंस विल डू सम डिस्टॉर्शन, ओके। हाउ दैट वर्क्स वो भी मैं आपको समझाता हूं, ओके। नाउ व्हेन ग्रेविटी डिस्टॉर्ट्स लाइट रेस, अभी तो क्या था कि लेंस वाज डिस्टॉर्टिंग लाइट जो हम यूज करते हैं। अगर ग्रेविटी इस लाइट रे को डिस्टॉर्ट कर दे, राइट, तो व्हाट विल इट लीड टू? कर्विंग ऑफ लाइट, एंड दिस विल बी कॉल्ड ग्रेविटेशनल लेंसिंग। जो लाइट रेज को डिस्टॉर्ट करने का काम अगर ग्रेविटी कर दे तो इट वुड बी कॉल्ड ग्रेविटेशनल लेंसिंग। नाउ लेट मी एक्सप्लेन टू यू फर्स्ट अ लिटिल बिट, दिस इज नॉट इंपॉर्टेंट, एक बेसिक समझा रहा हूं आपको कि हमारी बॉडी में हमारे पास लेंसेज क्यों हैं। वी हैव एन आई लाइक दिस, बॉडी में एक नेचुरल लेंस होता है यहाँ पे आई में। व्हाट हैपेंस इज रेज कम फ्रॉम हियर एंड दे फॉर्म ऑन द रेटिना, हमारी आई में, एंड व्हेन दे फॉर्म ऑन द रेटिना वी आर एबल टू सी। दिस इज हाउ द नॉर्मल बॉडी वर्क्स, बॉडी आई वर्क्स। अब मान लो किसी की आई ऐसी है, अगेन दिस इज नॉट इंपॉर्टेंट, आई एम जस्ट एक्सप्लेनिंग द फंक्शन ऑफ अ लेंस, जिसमें इमेज आगे बन रही है, मतलब इट्स नॉट रीचिंग टिल द रेटिना, राइट। दिस मीन्स योर लेंस हैज टू मच पावर। इट इज अगेन, देखो यहां भी इट इज डिस्टॉर्टिंग द लाइट रेज, वॉट एवर लाइट इज कमिंग, इट इज चेंजिंग इट्स पाथ फॉर मेकिंग इट इजियर टू सी। तो यहां लेट्स से योर लेंस इज टू पावरफुल, या आपका डिस्टॉर्ट हो गया लेंस, तो आपकी इमेज यहां बन रही है, बट व्हाट यू नीडेड वाज हियर। सो दिस इज कॉल्ड मायोपिया एंड यू वुड नीड अ नेगेटिव पावर लेंस हियर, ताकि थोड़ी इसकी पावर कम करके इमेज को यहां बनाया जा सके। जो नेगेटिव पावर लोग हैं जैसे मैं हूं, उनके आईज में क्या हो रहा है कि इमेज आगे बन रही है यहां पे, जबकि बननी चाहिए रेटिना पे। और कई लोग हैं जिनका लेंस उतना पावरफुल नहीं है, तो उसमें क्या हो रहा है कि इमेज यहां बन रही है बहुत पीछे, तो उनको ढंग से नहीं दिखता, तो उनको चाहिए पॉजिटिव पावर। पॉजिटिव पावर मतलब एक और लेंस लगाना है ताकि दी इमेज फॉर्म्स हियर, राइट। सो आपको लेंस का मतलब समझ आ रहा है, इट इज डिस्टॉर्शन। इफ यू हैव अ नॉर्मल आई, योर आई लेंस इज जस्ट मेकिंग द इमेज एट द राइट प्लेस। इफ यू हैव अ बैड आई, राइट, दीज आर बोथ abnormal. First is your lens becomes too powerful. अगर आप ज्यादा स्क्रीन रीडिंग करते हैं, ज्यादा you study a lot, you will most likely develop this lens power which is positive. तो अगर आपका लेंस, आई का लेंस बहुत पॉजिटिव हो गया, बहुत ज्यादा आपका आई का लेंस पावरफुल हो गया, तो रेटिना पे इमेज नहीं बनेगी, राइट। बट इफ देन यू विल नीड टू पुट अ नेगेटिव पावर लेंस इन फ्रंट ऑफ इट, कि यार चलो इसकी पावर थोड़ी कम हो जाए। अगर आप your lens becomes too less powerful, then you will need a positive power lens that the image needs to form here. So basically ये बात है कि lens is something that distorts light rays. अब यही काम अगर gravity करने लगे, right, तो it will be called gravitational lensing. देखते हैं ये कैसे काम करता है। देखो, let's say this is a telescope, यहाँ पे, ठीक है, this is a satellite or a galaxy that I want to see, right? Now यहां से लाइट रेज आती है, फ्रॉम दिस सैटेलाइट लाइट रेज कम लाइक दिस। बीच में देयर इज एन एंशिएंट गैलेक्सी, another huge galaxy is there in middle, so there is one place, this is where I'm seeing from the telescope. Now ideally अगर मैं टेलीस्कोप से ऐसे देख रहा हूं, if light only traveled in a straight line, तो मुझे ये तो दिखता ही नहीं कभी, I would just see this, right? जैसे this is my hand and I have kept something behind my hand, यहाँ पे there is no appreciable gravity, so you cannot see what is behind my hand because light is traveling in a very straight line. So light here would travel in a straight line, and बीच में ये आ जाता तो मुझे ये कभी दिखता ही नहीं, ये ऑरेंज कलर. But light does not always travel in a straight line when there is a lot of gravity present. अब ये ancient galaxy में बहुत ज्यादा gravitational force है, right? This can bend the space around it. Okay, so when light starts to come from this dark dwarf or whatever this orange thing you want to call, जो मैं देखना चाहता हूँ, it starts coming like this, then it is bent by this ancient galaxy in the middle because of its gravity, and somehow because of that it reaches here. अब ये आपको शायद ये डायग्राम नहीं समझ आएगा because it is a 2-dimensional one. This thing is happening in 3 dimensions, right? But अगर मेरे पास ये लाइट यहाँ पहुंच जाती है due to bending, the ray diagram is not important, the concept is important. There is something in the middle having gravity that can bend light. Because it can bend light, it reaches here. Okay, because it reaches here, I am able to see this. So light rays are getting distorted, making it easier for me to see something जो मैं normally नहीं देख पाता. Normally I would not be able to see this if light was traveling in a straight line, but in this case I would be able to see this. Okay, this is gravitational lensing. Now just imagine what I would actually see in the telescope when I'm looked from here. Just imagine and look from here. I would see this blue color galaxy and light traveling around it like a ring, because ये तो 2 ही rays हैं, but there would be a 3-dimensional, right? ऐसे rays आ रही होंगी, so a ring would be visible. This ring is called an Einstein ring. So this is what my image would look like because of gravitational lensing, and this is the actual picture of an Einstein ring captured by the Hubble telescope. This must have been the ancient galaxy that is providing the bending, and ये उसके पीछे की चीज भी I am able to see. So because of gravity, I am able to see things which I normally would not be able to see if light was only traveling in a straight line. This is the idea of gravitational lensing, right? You just need to understand the concept, and you need to know this term, Einstein ring. Most likely, if the question would be there, they would ask you that the Einstein ring is an application of gravitational lensing. And I think with this diagram, things become clear to you, right? Okay. Now, यहाँ तक clear है? Can I move forward? Again, ये conceptual चीज़ है तो slow चलेंगे. आगे we'll do defense, वो उतना conceptual नहीं है. There we'll go fast. Okay. Now, let's move to the special theory of relativity. देखो, what did Einstein say? Einstein's general theory of relativity was that gravity bends space. What is the special theory of relativity? Special theory of relativity was that speed of light is always the same between 2 points. So between 2 points, between point A and point B, the speed of light always remains same. Now, अब ये कैसे possible है? If one place gravity curves the space and in the other place it doesn't do it. एक जगह है, मान लो ये point A है, ये point B है, एक टाइम पे तो gravity curve कर रही है, सेम डिस्टेंस पे कहीं और ग्रेविटी है ही नहीं बीच में, तो देयर इज नो कर्विंग, राइट? तो फिर कैसे स्पीड सेम रह सकती है? स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम, बट डिस्टेंस तो चेंज हो गया इन बोथ दीज केसेस, राइट? If in the first case you go from this point to this point and there is earth, the light beam's distance is different. In the second case the light beam's distance is the same. So अब अगर दोनों cases में the distance is different but the speed has to be same, so what needs to change? There is only one more variable remaining. In this case, in the first case, when there was gravity between, or some gravitational object between these points, so there will be bending. So distance is here, distance will be more. Here distance will be less. But it was observed that speed of light is always same. So it was meant that gravity also will have to change time, dilate time for this to work. If the speed of light has to be same, right? If constant speed has to be there, distance has gone up in this first case, then time also has to go up. So time is not a fixed quantity, right? What does this mean? When there is high gravity, right? When there is high gravity, time will also change. Time will also dilate. Time will also increase. This is the relation between time travel and black holes, right? Because black holes have so much gravity that they can even dilate time. Okay. And here we also have to understand कि Earth पे gravity ज़्यादा है, satellites वाली जगह पे gravity कम है. So when we were reading timing services in GPS satellites, this is also another thing that they do, because time is a function of gravity also. Time is also dilated by gravity. Again, this is too complex physics, not important. If you can just understand that speed of light remains same, since the distance changes if gravity is present. यहाँ पर planet है, यहाँ पे कोई planet नहीं है, कोई कुछ नहीं है बीच में. So distance has changed, speed has to stay same, so time also has to change, right? Now, how detailed and how difficult this is, you can understand from the movie Interstellar, जो मुझे आज तक समझ नहीं आई है, but we don't need to understand that. Okay, we just need to get an idea here. So there are certain conclusions. These are the things you need to remember. Gravity is bending of space-time, right? Bending of space, general theory of relativity. Bending of time, special theory of relativity. Understanding black holes and how we photograph them, event horizon, etc. Special theory of relativity, space-time concept, and gravitational waves in case of cataclysmic events in space, right? These are the conclusions. Directly अगर आपको सिर्फ ये भी याद रह जाता है तो काम चल जाएगा, right? But the basics and the background is important. Okay, now अब इनसे questions कैसे आते हैं, right? वो हम आज देखेंगे. We'll see those questions today. Okay, now there is something called a tidal disruption event. We just need to understand what this means. इसका क्या मतलब है कि एक black hole है, like there is a black hole like this. This is a black hole. If a star gets too close to it, if a star is, let's say, revolving in the universe and it gets too close to a black hole, what will happen? The black hole will stretch the star because gravity will pull it in. So star ऐसे stretch होगा and then it will burst. Black hole has so much gravity that if a star comes close to it, it will stretch it and then the star will burst. This is a tidal disruption event. Okay, gravitational forces stretch a star and the star will be ripped apart. All right. Okay, now there is a binary supermassive black hole system, right? What does this mean? Binary means two black holes. Supermassive, ये हमने देखा था, this is a category of black hole. Black hole system means they are connected in some way, maybe they are revolving around each other. Was discovered through gravitational lensing of blazar. What does this mean? That blazar is a type of celestial body, right? It is a type of star. What it is not really that important. It is energetic, luminous. It is a type of star. इसकी gravitational lensing के through we were able to see a binary system of black holes, right? Again, how it works is not important, but if the terms are clear to you, the idea is clear to you, you will be able to answer the questions. And I'll show you all the previous year questions they have asked. In the past 10 years, they have asked about 5 to 6 questions from this concept. All of them very basic, right? Much more basic than what we have studied. So आगे के लिए also we are prepared. Okay. अब इसकी significance क्या है? Future detection of gravitational waves में help हो सकती है. This is a binary supermassive black hole. Now, when are gravitational waves created? When a star explodes asymmetrically like a supernova, when two big stars orbit each other, when gravitational objects move at very high speed. इसका relation क्या है? This you don't need to remember or understand. For this I'll have to explain E equals mc squared. Let's just not go there. or two black holes orbit each other and merge. These are the conditions where a gravitational wave could be created. Okay, all right. Now, next concept we have to understand is the James Webb Space Telescope. हमें पता है where it is going. It has gone to L2, right? अब ये है बिल्कुल normal theoretical चीज. So this we will run through quickly. We've read James Webb Space Telescope. It goes to point L2. ये हमें पता है. What is L2? We know. It is a collaboration between NASA, European Space Agency and Canadian Space Agency. Basic information. It was formerly called the Next Generation Space Telescope. Now what is the important thing here? It is an infrared observatory. जैसे हमने एस्ट्रोसैट देखा था. एस्ट्रोसैट was observing multi-wavelength three things, right? But James Webb Space Telescope only observes infrared. It is only infrared observatory. Okay, so ये एक important point है that you have to remember. What is its goals? देखो, कोई भी ऐसा मिशन होगा तो उसके क्या ही goals होंगे. If you're sending a telescope into space, what would be its goals? You would want to search for galaxies. You would see how galaxies evolved, how the universe evolved, how the universe works, how black holes work, etc., etc. So these goals, when you get it, unless something बहुत ही outlandish है, so the answer will be all of the above, because it's meant जैसे star formation, first stages of formation of stars, physical and chemical properties of planets, all of these things it's normally going to do, right? It's normally going to do anyway if you sent a telescope in space. This is its normal job, right? एक चीज यहाँ पे है expanding universe hypothesis or Big Bang theory. Now this is again geography, but I'll explain a little bit, right? Big Bang was the first ever like explosion that happened, right? And that led to the creation of the universe, right? अब इसे expanding universe hypothesis क्यों कहते हैं? When Edwin Hubble, जिसके नाम पे Hubble telescope है, Edwin Hubble ने क्या देखा? He had a telescope, okay, and he was looking at galaxies. Now galaxies say there was some electromagnetic radiation coming, right? There was some electromagnetic radiation coming from a galaxy. Now what he saw was an idea called redshift. Now what does this mean? He saw that जो galaxy है, all galaxies were constantly moving away from us. How? देखो, and how did he see that? इसने ये टेलीस्कोप में देखा कि देखो, this is a galaxy. It is constantly moving away from us. All galaxies are constantly moving away from us. तो अगर मैं टेलीस्कोप पे देखूं, so what would happen if this is the original electromagnetic radiation that I'm observing from the galaxy, or I'm observing from a star? It would become like this. Like थोड़े टाइम पहले ये ऐसी थी, and then it becomes like this. Over time, this is what was happening because all galaxies were moving away, right? This is what he observed. Why would this be called a redshift? Because when we were reading the visible spectrum, we read Vibgyor. R had the minimum energy. Minimum energy means longest wavelength, and the least frequency. This we know. So it was again observed. This still has not been explained. We have not explained why universe is constantly expanding, but we have observed that things are going really, really far. Okay, all galaxies are just moving away from us, constantly going away from us. And this idea, the radiation that they are emitting are becoming like this. So the original wavelength was this much. Now the new wavelength is this much. The wavelength is increasing. So wavelength is becoming longer. And since red color has the longest wavelength, this phenomena was called redshift. Edwin Hubble, he found this phenomena of redshift, and on the basis of that, it was decided, or it was observed, that universe is constantly expanding. How it is happening, we don't know. इसके पीछे there are two things called dark matter and dark energy, which we'll study just after this, right? बट एक्सपैंडिंग यूनिवर्स हाइपोथेसिस का मतलब ये है बिकॉज व्हेन वी सी थिंग्स ऑन अ सैटेलाइट वी ऑब्जर्व अ रेड शिफ्ट, seeing that things are constantly moving away from us, constantly the universe is expanding. How? We don't know yet. Okay, now moving back to James Webb Space Telescope, this is a collaboration between these three agencies. It is going to L2. It is an infrared observatory. Okay, now it has goals to observe star formation and planets, etc. This is fairly easy. It is headed for L2 and it is the successor of the Hubble Space Telescope. Earlier we had the Hubble. Hubble was named after Edwin Hubble, who saw this phenomena of redshift. Now, what are the points, what are the reasons for putting it on L2? Of course, one we have already seen, that there is gravity balanced on L2. एक चीज मैं आपको और recommend करूंगा. If you have to understand gravity in your everyday life, just look at it as a force. Unless you are dealing with celestial things, it's better to look at it as a force because force explains it much easier. If you try to understand the Earth's gravity as bending of space, it will take you at least 4 to 5 hours of research to understand why that happens. You will have to solve something called the Schrodinger equation. Okay, so till you have to understand at your level, just stay with force. देखो बहुत easy है to get dragged into science and to go very detailed into it, but वो पूछ नहीं रहे हैं इतना, हम सिर्फ एक आइडिया ले रहे हैं, जितना वो पूछ रहे हैं हम उससे एक लेवल ऊपर जा रहे हैं बस, राइट? ओके, L2 पे हमें क्या पता था कि एक तो ग्रेविटी बैलेंस हो रही थी, दिस वी सॉ. इट कैन कम्युनिकेट विद द अर्थ एंड विदाउट चांसेस ऑफ एक्लिप्स इट कैन सी अ क्लियर व्यू ऑफ डीप स्पेस. वेयर वाज L2? दिस वाज द सन, दिस वाज अर्थ, दिस इज L2. अब अर्थ सन के बीच में कोई भी रिलेशन हो, आप L2 से बाकी डीप स्पेस आराम से देख सकते हो, राइट? एंड देयर इज द सन बिहाइंड इट, तो सन से क्या मिलेगी? सोलर एनर्जी. So these were the advantages of putting it on L2, right? Now it has provided astronomers with a glimpse of the early universe, right? We are able to see the early universe because of James Webb Space Telescope. How? Okay, and what does early universe mean? देखो, speed equals distance upon time. Speed of light into 1 year means the term light year. This is the distance traveled by light in 1 year, right? Distance traveled by light in 1 year is 1 light year. Okay, so light year is a unit of distance, not a unit of speed. अब देखो, मान लो यहां से एक लाइट एमिट हुई, लाइट से क्या मिलेगा? मुझे इमेज मिलेगी. अगर मेरी इस बॉटल से कोई लाइट इमिट होके मुझे आईज तक आ रही है, सो आई एम एबल टू सी अ इमेज ऑफ दिस बॉटल. इफ दिस लाइट एमिशन, राइट, इट टेक्स 1 year to reach me, right? So what will I see? I will see the image that was there 1 year earlier, not the image that is there today, because जो इमेज बनी है उसको मेरे तक पहुंचने में 1 साल लगता है. So I will see there will be a time lag of 1 year. So technically I will be looking at the past. I will be looking at what is happening 1 year earlier, right? If the distance is measured, if the distance is so much that even light takes 1 year to travel, when this reaches my eye, only then I'll be able to see it, right? So this is light year. If I am using a satellite to look at the universe जिसका light बहुत ज़्यादा light years में distance है, so I will be able to see the early universe, not as the universe as it is today. Okay, it has captured an image of this galaxy, again galaxy merger of early universe, and it is visible because of gravitational lensing. You know the terms, your job is done. James Webb Space Telescope की 2 sides है. One side यहाँ पे है sun, यहाँ पे है earth, यहाँ पे L2 पे located है. एक साइड में तो इसे sun से हीट लेनी है, इसे कम्युनिकेट करना है अर्थ के साथ, राइट? दिस इज द हॉट साइड. सो ऑन वन साइड इट हैज टू टेक द हीट फ्रॉम द सन. ओके, नाउ इफ इट हैज टू टेक द हीट फ्रॉम द सन, दिस इज अ हॉट साइड. Earth is also here, so this is a communication side also. The other side is a cold side. This is the side where it has to look. it has to look into the other part of the universe. So here is where the mirrors are. The actual telescope is where the actual scientific instruments are. So there are two sides. There's the hot side, there's a cold side. Okay. Now, what are the key features of James Webb Space Telescope? Right? It views the universe in infrared. Okay. So infrared, we have seen it is an infrared observatory. Why infrared? Because of just related with the red shift. It's zyada I'm not explaining. This you'll at least have to remember, right? It is the only specialized infrared telescope in space जहाँ पे कुछ भी और, like it's not looking at a multi-wavelength thing जैसा AstroSat था. It is only specialized infrared telescope. Now, its primary mirror is 6.5 meters. There is a secondary mirror also. What are these mirrors? These are parts of the telescope. It's at L2. It has a sun shield. Sun shield matlab it has to take energy from the sun, but it cannot get heated up from the sun. So it is a sun. It has a sun shield. Kis side pe hogi sun shield? Obviously on the hot side. Now, what are the major instruments on it? There is the integrated science instrument module. There are three major payloads. First is the ISIM, then is the optical telescope element, then is the spacecraft element. ये तीन हैं, right? इसमें कौन कौन से इंस्ट्रूमेंट्स हैं? देखो, जहां भी तुम्हें इंफ्रारेड दिखे वो तो इसमें होगा ही. But if you see in the MCQ that there is a instrument here that has the word UV, that has the word X-ray, then you mark it wrong. अगर infrared है तो obviously it's going to be on the JWST. Understood? Okay. Now what will it do? Early universe, exoplanets, outer planets, small worlds, etc. This it will understand. Now, what are the observations that it has made already? First, it has observed Jupiter, right? Now, it has seen massive storms, auroras, faint rings, and two small moons. These are their names, right? Again, static information, just read from here. Jupiter पे उसने क्या क्या देखा है and what are the things you need to understand? एक तो Jupiter also has rings, but not as not as prominent as Saturn. Then it has moons, and it has the maximum number of moons in our solar system. It is and these are the four largest moons. Europa and Ganymede are the most important, right? Again, ये geography है. Great red spot, that is the storm that is happening in Jupiter. This is the great red spot here. बहुत time से the storm is going on. Jupiter is a gas giant, I hope you know, right? So it's made up of hydrogen and helium mostly. And auroras, this happens on Earth also. This is again geography. It's the interaction of magnetic field of sun with our north and south pole. It happens on Earth. So similarly, the magnetic discharge or the solar flares interacting with Jupiter's magnetic field would lead to auroras there. Again, ये geography है, तो please जब आप space tech पढ़ रहे हैं तो geography से space वाले chapters revise कर लो, right? Okay. Now, what other thing it has seen except for Jupiter? It has seen pillars of creation. Now, pillars of creation are places where new stars are forming within dense clouds of gas and dust. This we have already seen, right? That we understood कि nebula के अंदर stars बनते हैं. So they are three-dimensional pillars, right? And they at some times they emit semi-transparent near infrared light, and this is why this infrared observatory can see these pillars of creation, places where stars are being formed, new stars are being formed. These are pillars of creation. ये भी उसने देखा है. This is one of the images, the actual image from the James Webb Space Telescope, something that we were never able to see before. ये है क्या? We'll just see. अभी मैं आपको आगे बताऊंगा ये actually हो क्या रहा है. But this is basically star formation happening in a nebula, something called a cosmic cliff. We'll just see what it is. Okay. So this is one of the images that it has shown to us. All right. Now, other thing it has observed is exomoons, and Indian Institute of Astrophysics में they have developed a model to trace habitable exomoons. Habitable means places where we can possibly live, with the help of the JWST. How do you get or how do you see them? इसका एक model बनाया है. Now, what are exomoons? They are natural satellites that revolve around exoplanets. What are exoplanets? Planets outside the solar system. So outside the solar system जो planets हैं, उनके जो moons हैं where we can possibly live, those can be looked at using James Webb Space Telescope, और उसका एक मॉडल बनाया है at the Indian Institute of Astrophysics, right? 5,000 exoplanets have been discovered and natural satellites remain untraced, right? तो exoplanet तो हमने बहुत discover कर लिए, but the natural satellites are untraced, so that is why we have formed this model. Okay, now these are the other observations that James Webb Space Telescope has done, right? Now अब यहाँ पे again I will do a recommendation to you. Just know these terms, right? Just we have to understand these terms. SMACS 0723, it is a cluster of galaxies. WASP 96b, it is a planet outside our solar system. Southern Ring Nebula, it is a planetary nebula. Stephan's Quintet, this is a set of galaxies. Carina Nebula and Cosmic Cliffs, this is what we have seen in that picture. This was the name of the nebula, and these were the cosmic cliffs, places where stars were forming. And it has seen Einstein ring. This also we have understood what an Einstein ring is, right? So you need to remember these terms, what they basically are, and just that they are observed with JWST, not in detail also, right? Okay, there are some other terms like Kuiper belt. Again, geography hai, just read from here. I'm not going to explain what Kuiper belt, asteroid belt, exoplanet and nebula is. यहाँ लिखा है, you can read it, but this is basically geography, and I expect कि इतना आपको आता है, especially if you are giving prelims this year. If not, when you read geography, it will be fairly clear. Okay, now this is a comparison between Hubble, Webb and the Herschel Space Observatory. This Herschel is also planned for the L2, right? So this is again a small comparison table. As you can see, James Webb Space Telescope looks at newborn galaxies, so 13.5 billion years ago. Hubble's main job is to look at young galaxies 12.5 billion years ago. So why 12.5 billion years ago? It will look at places whose distance is 12.5 billion light years. So you're looking at it today, but since light has taken 12.5 billion years to travel, you are seeing something 12.5 billion years back. Okay, this is an important thing. Is Hubble serviceable? Yes, because it's in the low Earth orbit. Is Webb serviceable? If there is a problem in JWST, can we go there? No, because it's 1.5 million kilometers away in the L2 point, right? But again, ab dur dekhna hai, so you'll have to place the thing far. But again, then the problem is, if it develops a problem, you cannot go and service it. What are the wavelengths? Here you can see again infrared and submillimeter, only infrared, and yahan pe visible, UV and near infrared. So Hubble is multi-wavelength, but Webb and Herschel are mainly focused on infrared. Okay, now let's go to the Parker Space Probe. Parker Space Probe is NASA's mission, a mission that has flown through the sun's upper atmosphere. It is a space mission that has actually touched the sun, right? And it is part of NASA's Living with a Star program. All right, named after this person, it has a carbon shield to protect from sun's heat. Now, it is the first spacecraft in history to touch the sun. The important thing that you will forget or mark wrong, it uses a series of gravitational encounters with the planet Venus to go to the sun, not the planet Mercury. जब हम सोच रहे होंगे in the prelims, if it says that Parker Space Probe used a series of gravitational encounters with Mercury to touch the sun, it would seem correct कि Mercury sun के पास है, तो Mercury की gravity को use करके it must have touched the sun. But the idea here is, this is a statement, this is a fact that it has used the gravity of Venus, right? So these things you remember and you highlight specifically. All right, okay, these are the layers of the sun. Yeah, again geography hai, but I've written how I used to remember it. I did not have a very good mnemonic. If you have it, you can mention it in the discussion ताकि सबकी help हो जाए. This is how I remembered it: Korakov, Chrome and Corona. Korakov, I could remember Korakov because the sounds that you hear when you take a patient's blood pressure, those sounds are called Korakov sounds. Okay, So that is, I mean, that's how I could remember it, but you can use a different mnemonic. These are the layers. There's a core, there's a radiative zone, convection zone, photosphere, chromosphere, and corona at the top. These are the 6 layers. This they can ask you. Now, again, अब देखो अगर ऐसा कुछ आ जाए कि what is the relevance of Parker Space Probe, इसका फायदा क्या है? तो भाई सन की evolution, extreme weather events, solar storms, solar flares and solar storms, ये हम अभी पढ़ेंगे, right? What happens in solar storm, etc. These things it will do because इसका काम है सन को study करना, right? What is India's mission to study the sun? That is called Aditya L1 mission. Okay, that is India's mission to study the sun. Let's continue with solar flares. So what are they? They are sudden explosion of energy, okay, caused by reorganizing of magnetic field lines near sunspots. Basically क्या होता है? There is some change happening in the magnetic field of the sun. Sun has a magnetic cycle, right? In the magnetic cycle, inside the sun, there is a dynamo mechanism. So let's say this is the sun. It has in its inside 2 magnetic particles like this. Okay. In the deep interior of the sun, because of its magnetic cycle or the changes in the sun's magnetic field, these 2 things that develop like spots develop. They are dark spots developing inside the sun due to the magnetic field of sun. This is called a solar dynamo mechanism. These dark spots are also called sunspots. Okay, dark spots are also called sunspots. Now, they appear dark. Why are they appearing dark? They appear dark because they are cooler than the other parts of the sun. Right? Sunspots are cooler than the other parts of the sun. Right? Now, inside the sun, due to some magnetic field changes, these dark spots develop. Then after some time, they come to the surface of the sun. When they come to the surface of the sun, right, they can cause the release of plasma and hot gases from the sun. This release is called a solar flare. The magnetic field of the sun has led to the creation of these dark spots. Where are they created? They are created in the interior. When they come to the surface, they lead to release of certain plasma and hot gases. Okay, when they lead to this release of plasma and hot gases, this is called a solar flare. What actually is being released is a high energy X-ray radiation, right? High energy X-ray radiation and highly accelerated charged particles are leaving the sun's surface because of these solar spots or sunspots. So hot plasma, high energy X-ray radiation, charged particles, they are being released from the sun's surface. Now, what is the outermost layer of the sun? It is a corona, right? So it is called the coronal mass ejection because many things en masse are being released from the sun's surface. So it is called a coronal mass ejection. Happening why? Happening due to the sun's magnetic field. Because of the sun's magnetic field, this is happening, right? This is a solar flare happening due to the sun's magnetic field. Highly accelerated charged particles are leaving. Hot plasma, coronal mass ejection. This much is clear? Okay. Now, energy, radiation and high energy particles emitted by solar flares, right? So there is release of energy, there is X-ray radiation, there is high energy particles, there is plasma that is released due to the formation of these sunspots from the sun. Right? Now, Earth itself has a magnetic field. All of this was happening because of sun's magnetic field. Some changes in the sun's magnetic field, solar flare was happening. Earth also has a magnetic field. Earth's magnetic field, if I was to observe, right, if let's say this is the North Pole and this is the South, okay, I'll just draw it normally only. Let's say this is the North Pole and this is the South Pole. Earth's magnetic field looks something like this. These lines depict the magnetic field of the Earth. So at the North Pole, the magnetic field lines are closest to the surface. Same at the South Pole. Right? At the North and South Pole, the magnetic field lines are closest to the surface. Why this is there, you don't need to know, or if you need to know, you have to read in geography. But at the place of the North Pole, the magnetic field lines are closest to the Earth's surface. Again, same at the South Pole. So when certain magnetic field elements are released from the sun, they interact with the magnetic field of the Earth. They interact with the magnetic field of the Earth. This interaction leads to the formation of auroras. What is aurora? You must have seen those images of northern lights, right? Those beautiful lights that are occurring in the sky at the North and the South Pole. Those are the auroras, right? When solar wind or solar flares or particles from the sun that are emitted due to the magnetic field of the sun interact with the Earth's magnetic field, they will interact everywhere. But where will we be able to see them? We will be able to see them where the magnetic field is closest to the surface. That is true for the North Pole. That is true for the South Pole. So there we see aurora lights, right? Aurora or northern lights or southern lights, same. Now auroras in the northern hemisphere are called aurora borealis and aurora borealis or northern lights, and in the southern hemisphere aurora australis or southern lights. If you have to remember this, what you will have to remember, Australia is on the southern pole, close to the southern pole. So you remember from here, right? Aurora australis, southern hemisphere, southern lights. Aurora borealis, this is boreal forest. If you read geography, you will realize that boreal forests are in the northern plains, northern part of the world. Or aurora polaris, these are the northern lights. So because the Earth's magnetic field interacts with the magnetic radiation or solar wind or solar flare released by the sun, but this interaction happens maximum, or we are able to see it maximum at the place where the magnetic field is closest to the surface. It leads to the formation of lights, which I'm sure you must have seen. If you haven't, just Google northern lights and you'll see what it looks like. These are called auroras. At the North Pole, it will be called aurora borealis. At here, it will be called aurora polaris. Okay. All right. Now, what are the possible effects of this solar flare on Earth? Therefore, these are release of magnetic particles, magnetically charged particles from the sun, right? So these can have an effect on what things? जो भी हमारी communication systems हैं, right? Where we are using electromagnetic radiation, electromagnetic spectrum we have understood. जहां हम ये spectrum use कर रहे हैं, वहां पर ये interfere कर सकता है. Because as we have seen, any star like the sun emits the entire spectrum of EM waves, right? Pura spectrum of EM waves is emitted by something like the sun. Okay, so it can interact with the entire spectrum. तो जहां भी हम ये EM wave अपनी life में use कर रहे हैं, वहां there could be a possible problem, right? So what is the problem? There could be an effect on space missions. There could be an effect on radio transmissions, right? There could be damages to astronauts in outside spacecrafts. There could be damages to satellite communication systems, power distribution stations, and electronic equipment. Wherever we are using this electromagnetic wave, there might be a problem. Now, this is the classification. B has the least intensity, so least effect, and X has the maximum intensity, so maximum effect. Classification is not that important, but the effect, what it can affect and what it can't affect, and the concept that it is happening due to magnetic field of sun and there is interaction with magnetic field of Earth, because obviously magnets will interact. right? This is important. Now, what is a solar cycle? This is the change in the magnetic field of the sun. So every 11 years, sun's magnetic field completely flips. Okay, that is, the sun's global, like sun's magnetic north will become the sun's magnetic south, and the sun's magnetic south will become the sun's magnetic north. Every 11 years this is happening. Now, this change can be tracked by sunspots. Why can it be tracked? Because sunspots are generated because of the magnetic field. If there is a change in the direction of magnetic field, there will be a change in the direction of sunspots. If there is a change in the direction of sunspots, we will be able to track whether there has been a change or not, right? If the new solar cycle starts, that means again there is a change. Like, let's say this was the north and south, and the new cycle has started, so it becomes like this. At this time, the number of sunspots will go back to minimum because the magnetic field has now reset. Now again sunspots will start producing, so this time is called a solar minimum. Okay, then again when it starts to form, then the sunspots will grow. So by tracking sunspots, I can also track a solar cycle that changes every 11 years. Okay, is this much clear? Next thing we have to study is NASA's Artemis 1 mission. Artemis 1 mission is meant to build a long-term human presence at the moon, right? What is it? It is so it is basically, you want to build on moon a long-term human presence. Okay, so you want to establish people there for a long term. So what are we doing right now? NASA right now is taking an uncrewed flight test. That means without crew, they are sending a test flight to the moon, right? And then once that is established, then they will start sending crew also. Okay, they are planning to land the first woman on the moon with this Artemis mission, right? Okay, so Artemis 1 has three main components. It is the space launch system. Just one second. Okay, so it is the space launch system rocket, SLS rocket, space launch system. It is the most powerful rocket in the world that can take you to deep space, right? Deep space is beyond the solar system or beyond the Earth's, like moon and Earth. And if you go into interplanetary exploration, that would be deep space. So it's possible of taking you to deep space. This is the first thing they want to test. They are basically testing that will we be able to take people across the globe to different planets, etc. For that, they have the Artemis mission. First, they're taking it to the space launch system rocket, or a rocket that will take them to deep space. The second thing is the spacecraft. The spacecraft is what will carry the astronauts, right? It is the only spacecraft that is capable of crewed deep space flight, right? So they are testing these three things: space launch system rocket, Orion spacecraft, and ground systems at the Kennedy Space Center. So ground at the Kennedy Space Center they're testing, the Orion spacecraft they're testing, and the space launch system they're testing. These three things they are testing with this Artemis 1, so that future, if we have to do deep space exploration, it can be done. All right. Now, what are the objectives? First, Orion is the thing that carries the the astronauts. Its heat shield has to be tested. That when it is in high heat conditions, when it's leaving the atmosphere, when it's entering the atmosphere, it can, tolerate that heat. Okay. Then radiation environment of deep space. All right. Then once it comes back to Earth, it will obviously be made to splash down in the ocean. So wahan se can we retrieve it, right? Then flight test objectives and study the moon, because they're trying to go to the moon. So these are the objectives of the Artemis 1 mission. One other objective is to put the first woman on the moon. All right. Okay. These are some of the other lunar missions by other countries that you just have to see. It's a table here. I'm not reading this. You can read from the slides. Now, okay. So now when the Orion spacecraft, this is the spacecraft that will carry the astronauts. Currently we have sent an uncrewed one, to test it. If everything goes well, then we'll send the crew. So once it goes closer to the moon, it uses something called a retrograde orbit, right? So here what you need to know is that when Orion goes to the moon, it will use a retrograde orbit, and this retrograde orbit will help it come back to Earth when it needs to. Okay, so it will stay in this orbit, and come back to Earth, it will get some gravity assist from this retrograde orbit. Now, what is a retrograde orbit and what is a prograde orbit? If the Earth, like this is the direction in which Earth is revolving around the sun. Okay, if the Earth's rotation is in the same direction, the direction of the Earth's rotation is in line with the revolution direction, it will be called a prograde orbit. Earth is going like this around the sun in this direction. If Earth also rotates in this direction, it will be called a prograde orbit. If something is going around the sun like this, but it rotates in this direction, it will be called a retrograde orbit, right? Just the meaning of the term is enough. If it is rotating like this, opposite to its direction of revolution, it will be called a retrograde orbit. If it is rotating like this, similar to its direction of revolution, it will be called a prograde orbit. All right, next we have to see space sustainability. अब देखो, let's do word breakdown. What does sustainability mean? ये मुझे बताओ यार comments में. What does it, if I say sustainable development? Okay, what do you understand? What does the word sustainability mean? Sustainable development. Okay, what would that mean? It is development that takes care of the present generation. आज की जो generation है उसका need पूरा हो, and the needs of the future generation. Okay, so sustainable development is if there is needs of the present generation and needs of the future generation, they are both met, right? This is called sustainable development. So what would be space sustainability? Space sustainability would be sustainability in space for sustainability of Earth would mean that we are using space in such a manner that today's needs are also met, and future generations, when they need to use space, they would also meet, their needs would also be met. If we launch too many satellites today and then we don't retrieve them back, we create a lot of space debris, then for future generations it will lead to a lot of problems. So right now what we are doing is sustainability. That means what we're trying to do, that today's needs are met but future generation needs are also met. When you are doing sustainable development, there are two concepts. Mains के लिए बता रहा हूँ. There are two concepts. There is intergenerational equity and there is intragenerational equity. Meaning that intergenerational means current generation, today's generation and future generation, they have, their needs are equally important, right? So you cannot just pollute today and forget about the next generation. Intragenerational equity means that within this generation everybody is equally important. This was asked in Means 2020. How are the ideas of intergenerational and intragenerational equity connected with sustainable development? So if you know the meaning of the words, it's very easy to write, right? Intergenerational equity means today's generation, future generation, same. Intragenerational means that everybody is equally important. All right, okay. So now what are we doing for space sustainability? There is a United Nations Office on Outer Space Affairs. Okay, they have with the collaboration of Government of Austria organized the World Space Forum. This is a platform to discuss space sustainability so that all humanity can continue to use outer space for peaceful purposes. Okay, what are the threats to space sustainability? Of course, one threat will be space debris and crowding of the orbit. Second threat would be militarization and weaponization of space. Like if you use anti-satellite weapons, when we see defense, we will see this. India also has anti-satellite weapon. Russia has anti-satellite weapon. These are the four countries. This is a weapon used to kill the satellite of other country, right? Let's say China launches a spy satellite over India and we go for a war. Now they are able to see our troop movements, so we will need a weapon to destroy that satellite. But what will happen when we destroy that satellite? So many pieces will form in the orbit and so much space debris will collect. Okay. Then there is rendezvous and proximity operations, meaning you are altering space objects to bring them close to each other. This is also done in case you want to destroy or interfere with somebody else's satellites. And then there is space weather. One idea of space weather is solar flare. Okay. One idea of space weather is solar flare. So these are the things that are threat to space sustainability, that might lead to space sustainability not being established, right? What are the initiatives for that? There is that we have taken globally. There is the UN Office on Outer Space Affairs. There is a conference on disarmament. There are guidelines on space sustainability by this stands for United Nations Committee on Peaceful Use of Outer Space. United Nations Committee on Peaceful Use of Outer Space. This is it should be like this, PUOS. So just correct this, please. United Nations Committee on Peaceful Use of Outer Space. Okay. There is a space sustainability rating, and there is a anti-satellite test ban resolution. That means you will not test for anti-satellite weapons. This was passed by the UNGA, but it was a non-binding resolution, since resolutions that are passed in the General Assembly of the United Nations are not binding on member countries. Only resolutions passed in the Security Council are binding on member countries. Okay, so it said you ban the testing of anti-satellite weapons. If you have to use it in war, you'll use it, but stop the testing. Okay, this is the initiatives. What are Indian initiatives? We have already seen space situational awareness. Then we are doing space weather monitoring, right? Near Earth objects monitoring. Project Netra we have seen. Then there is Digantra. Digantra is a space sector startup, and it is going to make India's first commercial space situational awareness observatory. There is a India-USA bilateral space situational awareness agreement. What is space situational awareness? We have read at the time of space debris. And there is a SPADEX. This is an in-orbit servicing platform by ISRO. Means that in orbit you can service the satellite when needed, so you don't have, its life will increase, so space debris will go down. Now the Committee on the Peaceful Use of Outer Space, it sees 5 agreements. They are written here, and I just expect you to read them. It's fairly easy. What the Outer Space Treaty is, what the Rescue Agreement is, Liability Convention is, Registration Convention is, and Moon Agreement is, right? This is a committee of the United Nations. One thing is Goldilocks zone. Ab dekho, again, this was asked in the prelims once, and people did not know what it is. But if you know the story of Goldilocks, right? What is the story of Goldilocks? That she wanted her porridge to be just not too hot, not too cold. So just perfect, right? So Goldilocks zone is that zone where the conditions are just perfect for a planet to have life, because water has to remain in liquid state. That temperature has to be there. If it's too cold, water will become ice. If it's too hot, water will become vapor. So that exact thing, right? Our Earth, for example, is in the sun's Goldilocks zone, exact zone where there will be no, there is the exact condition for formation of life. So recently this planet was discovered in the Goldilocks zone of some other star. Which star? Not important. Okay, just the term is important. Then there is Greased Lightning 10. Greased Lightning 10 is a plane by NASA, right? It has 10 engines, and what is the special thing? It can take off like a helicopter but fly like an aircraft, right? It can take off like a helicopter, fly like an aircraft. This is the special thing that they're testing. So this is Greased Lightning 10. Again, it's a PYQ, just need to know. Us time news mein tha, abhi news mein nahi hai. All right. Now, this is important. There is a Ice Cube Neutrino Observatory, right? Ice Cube Neutrino Observatory. It is an array of 5160 optical sensors buried inside a cubic kilometer of ice beneath the South Pole. Okay, beneath the South Pole, beneath 1 cubic kilometer of ice, this has been buried, right? All right. Why is it there for? It is there for understanding what neutrinos are and to detect dark matter. All right, now what is dark matter and dark energy, that we'll just see. But this is there to understand what neutrinos are and what dark matter is, right? When neutrinos interact, right, they give an idea of where dark matter is located, right? So to understand what dark matter is, we have created this ice cube neutrino observatory. Neutrino derives from the word neutron. Neutron and proton, we have already read, are there in the nucleus. So neutron's smaller element is the neutrino. What exactly neutrino is, we'll read when we read nuclear technology, nuclear fission and nuclear fusion. The last thing, that space that we've left, is dark matter and dark energy. Okay. Let me just explain that to you in brief. Okay. And then we'll do that in detail in the next class and then continue with defense. Okay. So there are two things: dark matter, just giving an explanation, just giving you an idea, not going into its detail. Dark energy, right? What did we read? We read the red shift. Red shift was happening because the universe is constantly expanding. Okay, but for anything to constantly expand, constantly grow, go away from us, some energy is needed. You need certain energy. This energy, so far we have not understood. We don't know what is causing this universe to expand. Okay, we have no idea. All right, so we have called it dark energy. We know what dark energy is not. हमें पता है कि ये नहीं हो सकता, ये नहीं हो सकता, it's not gravity, it's not this force, it's not that force, this we know. But what it actually is, we have no idea. It is what is causing the universe to expand. This is all we know, and this is called dark energy. Out of the entire universe, if I would say the entire universe is 100 units, matter that we can see and interact with, you, me, planets, sun, etc., this is just 5%. 70% of the universe is composed of dark energy, and we don't know what dark energy actually is. The other 25%, the remaining 25%, is dark matter. Now please don't confuse, dark matter is not black hole. Okay, black hole is what? Black hole is concentration of gravity at this one very small point, singularity. That is black hole. Dark matter is scattered matter in the universe. Okay, what is dark matter? I'll just explain. पहले dark energy समझते हैं. Universe is constantly expanding. This was seen through redshift because the wavelength was looking like this. It started looking like this. So we saw, okay, there is a red shift happening. Now this red shift could only be explained through a mysterious force called dark energy that makes up 70% of the universe. 5% is visible matter, or matter that we are always interacting with, that is around us, that is 5% normal matter. Now what is dark matter? Right. So when we saw galaxies are what? Galaxies are collections of stars and planets. Okay, collections of stars and planets. Now these stars and planets, they were together. Like we have the Milky Way galaxy. The sun is a star in the Milky Way galaxy. They have all come together and they are interacting with each other. They are joined together. Now, if we are to look at their gravitational force, if all these stars have come together, right? If all these stars have come together in something like a galaxy like this, gravity must have attracted them to keep them together. Like sun's gravity is attracting the earth. Gravity must have attracted them to keep them together. But when we mathematically studied the galaxies, we found that the gravity that is there of all the stars, this gravity is not enough. This gravity is not enough. It's the gravity generated, the bending generated, the force generated is not enough to keep all these stars together mathematically. So there must be some more gravity present. Where is this more gravity coming from? This more gravity is coming from certain particles that do not absorb or emit light. They do not absorb light, they do not emit light, but they have mass. If something does not absorb or emit light, it does not absorb light, it does not emit light, it will appear completely dark. If something has mass, it is called matter. So this is dark matter. It's not a black hole. Black hole is concentrated like this. Dark matter are scattered particles. They are providing the missing mass, missing gravity in the galaxy. Because when we account for dark matter, then we can say that gravity is enough to hold the stars together. So this is dark matter and dark energy. 14 is the cutoff, and there is a test of 16 questions now for you. All right, now let's do the answers. This one I'm not explaining because I explained yesterday. Gravitational constant is very small, so gravity यहाँ पे not correct लिखा है. Gravity cannot be the strongest force, right? Gravity actually is the weakest natural force. Okay, all right. Second, this I'll explain. देखो, this was asked in 2014. I have not taught you this. I don't care if you got it right or wrong, right? I am just showing you the sort of question they ask. So for this, what we're going to do, we're going to give you a table of all the important missions that are there, that are in the news this year. ऐसी चीजें आप mark करके रखो कि यार ये चीजें मुझे भूलेंगी. So I need to keep that for the last minute, right? Answer here is 2 and 3 because Cassini-Huygens is for Saturn, but this is not what they're going to ask you now. ये तो हो गया ना? This we have read. This option you should have gotten correct, but इससे आपको आंसर नहीं मिलता. Okay, just showing you the sort of questions. They will not repeat this exact question because that year these missions were in the news. Today they are not in the news, right? All right. यहाँ पे explanation है. Cassini-Huygens is actually for Saturn. The other two are correctly matched. All right. Then ice cube. Ice cube is a particle detector located at the South Pole. First thing is fine. Third thing is fine, right? Now let's look at this. The idea of telescope. ठीक है, telescope का मतलब is not only looking through lens. Telescope can also be an observatory. आपको ये लग रहा होगा कि something is buried deep in ice, तो फिर वो telescope कैसे हो सकता है, right? यही डाउट आया होगा कि अगर आपने deep bury कर दिया इसके अंदर, then how is it a telescope? अगर हमें बाहर की इलेक्ट्रोमैग्नेटिक रेडिएशन देखनी है टू चेक इफ समथिंग इज हैपनिंग. इलेक्ट्रोमैग्नेटिक रेडिएशन इज नॉट लिमिटेड बाय ऑब्जेक्ट्स इन इट्स बिटवीन इफ इट हैज हाई एनर्जी. क्या कह रहा हूं मैं? अगर मान लो मुझे एक्सरे डिटेक्ट करने हैं, इफ आई हैव टू डिटेक्ट एक्सरेज, एक्सरेज हम क्या करते हैं, हम बॉडी के थ्रू एक्सरे लेते हैं तो वो फिल्म पे एक ब्लैक कलर का ऐसे एक्सरे आ जाता है, राइट? सो एक्सरेज कैन पास थ्रू माय बॉडी, राइट? तो इफ देयर इज एन इलेक्ट्रोमैग्नेटिक रेडिएशन दैट हैज इनफ एनर्जी, इट विल बी एबल टू पास थ्रू स्टफ, राइट? इट विल बी एबल टू पास थ्रू स्टफ. जैसे एक्सरे कैन पास थ्रू माई बॉडी, लाइट कैन नॉट पास थ्रू बिकॉज लाइट में उतनी एनर्जी नहीं है, विजिबल लाइट, बट एक्सरे कैन पास, कॉस्मिक रेज कैन पास. अब खुद सोचो, अगर हमने किसी चीज को डार्क मैटर डिटेक्ट करने के लिए रखा है, डार्क मैटर अर्थ पे तो है नहीं, डार्क मैटर कहाँ है? डार्क मैटर है स्पेस में, फिर भी वी हैव बरीड इट डीप इन द आइस, राइट? आइस के अंदर हमने बरी किया है, फिर भी वी आर डिटेक्टिंग डार्क मैटर फ्रॉम स्पेस. सो व्हाट मस्ट बी हैपनिंग? सम रेडिएशंस मस्ट बी कमिंग that are able to cross this ice and still reach the ice cube, right? And if it is an observatory that looks at things in space, it can be called a telescope. Okay, traditionally telescope must have a mirror, but if it is an observatory, that is basically ये क्या कर रहा है? It is looking into space. That is what a telescope does. So it can be called a telescope, right? सिर्फ समझाने के लिए था ये क्वेश्चन. आई कुड हैव पुट द वर्ड टेलीस्कोप इन द स्लाइड ऑल्सो, तो आसान हो जाता. If you have marked this wrong, it's absolutely okay, but understand the concept now. Okay, this is it. Now this is very simple. This we have read, so I'm not explaining. It can take off like a helicopter, fly like a spacecraft. Now astrosat, what did I tell you? When there is data, be very skeptical about data. This statement is wrong, and this is also wrong because Japan also has one and many other countries have one. So first and second both are wrong. Now this basic factual question, again just to understand कि वो questions कैसे पूछते हैं. They did not ask मंगलयान कौन से उससे गया, what is the difference between an orbiter, a lander and a rover, what is it finding, what are its payloads. जो scientific चीज़ें हैं वो नहीं पूछ रहे, वो ब्यूरोक्रेटिक चीज़ें ही पूछ रहे हैं कि इंडिया फर्स्ट है क्या, इंडिया फर्स्ट टाइम में पहुंच गया क्या, थिंग्स लाइक दैट. एक बेसिक अंडरस्टैंडिंग लेके these are the things we're supposed to be dealing with. Answer here is 1 and 3 because other countries have also done this before us, and this we have studied when we were reading it, right? All right, and we were the fourth people to go, not the first, not the second. All right, okay. Now this we have already seen, ELISA detecting gravitational waves. ये वो conceptual पूछते हैं. तो अब देखो कितने questions हैं gravity पे. ELISA they asked gravitational waves in 2017, right? In 2017 they asked singularity event horizon connected with gravity and black hole, right? जब इनको प्यार हो जाता है किसी टॉपिक से, they'll keep asking it. Done? Okay. Then they, okay, let's look at this. Now again, IRNSS, this is navigation with Indian constellation, India's regional navigation system, correct? In 2018 they asked about IRNSS. Again, data. Wherever there is data like this, you can understand that it will be wrong because it's 1500 kilometer. Now you don't need to read option 3. So if in the prelims, actual prelims में आपको ऐसा हो कि time कम पड़ रहा है, you are in a fix and you are able to eliminate this. यहाँ आपने देख लिया 1 only या none, मत पढ़ना 3. It's only there to confuse you. Just don't read it if your time is less, otherwise you can read it. India will have its own satellite navigation system with full global coverage by the middle of 2019. Of course not. So this is also wrong. This statement is correct and we have read also, right? Okay. Now 2017 gravity asked twice, right? Into 2 times they asked gravity in 2017. In 2018 light is affected by gravity, universe is constantly expanding, matter warps its surrounding space-time. Okay, again 2018 gravity got repeated. Answer is D. All right, let's see आगे. 2018 next question, in which of the following areas can GPS technology be used? Why are we using GPS technology? For positioning, for timing. GPS is obviously used in phones. You can use it for banking also, timing and positioning, and you can use it for power grids also, timing and positioning. So answer is D. Wide thinking in science and tech. Okay, you know the idea of GPS, you know what trilateralization is. Wide thinking, fairly easy answer. All right. Now, with reference to India's satellite launch vehicles, consider the following statements. Now, PSLVs launch satellites useful for Earth resources monitoring. Polar satellite launch vehicle launching polar satellites for Earth resource monitoring. And GSLVs mainly to launch communication satellites, geosynchronous and geostationary. Satellite launched by PSLV appear permanently fixed in the same position. Of course not. This is true for geostationary, not for polar satellites. So second statement is wrong. Actually they have if the word here was GSLV, then it would be correct, right? So second statement is wrong. Third, GSLV Mark III is a 4-stage launch vehicle. No, PSLV is a 4-stage launch vehicle. Which is the stages? Solid, liquid, solid, liquid. Okay, answer here is 1 only. All right. Now 2017 gravity into 2, 2018 gravity, then 2019. Scientists observed the merger of giant black holes. Merger. If they were wanting to detect singularity, they did not need a merger of black holes. You could have just seen black holes directly through the Event Horizon Telescope. But merger of black holes, collision of black holes, cataclysmic events in space-time lead to what? Gravitational waves. Okay. All right. So we have seen 2017, 2018, 2019. Gravity 1, 2, 1, 1. All right. Okay. Then 2020. Eliza was asked. Okay, this they had asked before. Same thing they had asked before. Same thing they asked again. Right? 1 million kilometers long equilateral triangle. Why is it there? For gravitational waves. So again in 2020, gravity and gravitational waves repeated. Okay. All right. We have read this. Now 2021. Again, general and special theory of relativity. Right? General and special theory of relativity is gravity bending space-time. General theory explains that gravity can bend space-time, and how time comes into it is explained by special theory of relativity. ये आपको समझ नहीं आया शायद कई लोगों को, तो I'll just explain this at the end of all the questions. Astronomical distance measured in light years. Again same thing. Light years में क्यों distance measure कर रहे हैं? Distance, speed is equal to distance upon time. Speed into time is equal to distance. Speed of light is always the same. This we have already seen. And speed से ही relation होगा distance का. This is one way to solve it. Other way you can see the options. Distance among stellar bodies do not change. Of course, you know this is wrong because the universe is expanding. Gravity of stellar bodies do not change. This also you know, and this has nothing to do with distance anyway, right? Light always travels in straight line. This is also wrong. And speed of light is always the same. This is the thing that's correct. अब ये देखो, they have made it extreme here to give you a doubt. But when concepts are clear, you will not have a doubt. So again, gravity was repeated in 2021 also. Then this is the last question. Solar flare happens on Earth. Now, solar flare was due to magnetic movements on Sun. So whatever electromagnetic communication we are doing, that can be affected by solar flares. GPS could be affected, yes. Tsunami needs an earthquake to happen. This is basic geography. Tsunami needs an earthquake to happen. Second is wrong. Just eliminate second and you're done. Don't even read the rest. But we'll still read. Power grids, yes. Auroras, yes. Forest fire. Solar flare is a magnetic phenomena, not a heat-based phenomena. So the answer 5 you eliminate. Even if you could just eliminate 5, you would get the answer, which is C. Orbits of satellites, yes, because satellites are magnetic components. Short wave radio communication, yes, especially over polar regions, yes, because polar regions will have maximum interaction. Okay, now one question with regards to, are we done? Yeah, we're done. Okay, now one question with regards to what you were asking, how gravity changes time. Gravity bends space-time. This is the assumption of general theory of relativity. To explain the space component, we saw gravitational waves. To explain the time component, there is the special theory of relativity. What is the special theory? Special theory says speed of light. Speed is always same. Okay, all right. Regardless of what are the circumstances, speed of light is always same. First case is, this is point A, this is point B. Light travels in straight line. There is nothing in between these two things. Okay, distance between A and B, or let's say displacement between A and B, is the same. It will always be the same, right? Light is traveling in a straight line, so speed is equal to distance upon time. Now, regardless of the circumstances, what happens between A and B, the speed has to be the same. Now, what happens? Suddenly a star comes here. It was revolving and a star comes here. Now, because of the star, what will happen? There will be bending of the space. So light, how will light travel? Light will now travel like this because of the presence of the star. Okay. Light will now travel like this. But the distance between AB, light can travel any way it wants. Okay, light can choose to travel any way it wants. But the distance between A and B has not changed. Distance between A and B has not changed. Only the way light is traveling has changed. Right? Now, distance that light has traveled has increased. Distance that light has traveled has increased, but this equation S is equal to d by t cannot change. Distance, actual distance is same. So in the second equation, in the second case, S second, speed in the second case will be the new distance, I'll say nd upon the time. But the S second, the second case speed has to be same as the S1, the first case speed, right? Again, I'm going in such depth because there were questions. This much depth is not required. Okay. First case speed was distance between A and B divided by time. Second case distance S2 will be the new distance traveled. The new distance traveled by the light, distance between A dash and B dash divided by time of the second case. Okay. Now we have learned that S1 and S2 have to be the same because speed of light is always same. So distance between AB traveled in the first time divided by time 1 is same as distance between A dash and B dash and time 2. Now it's pretty clear that A dash and B dash, this distance is longer. So I can say, since this has to be equal, but this figure is bigger. So if distance between A and B, if DAB is 1 and this is T1 and this is 2 and this is T2, right? If I say distance A dash B dash is twice of that here, so I will get T2. In the second case, the time taken is 2 times into T1. So because of gravity, time has been dilated, increased. Because speed of light is constant, it has changed the distance light has to take. So it has changed the time light takes, right? And this time is dilated because of gravity. That's all you need to know. Changed due to gravity. So that is it for today.